as the slide says, my name is Jussi Nummelin, coming from a company called Kontena. In the presentation I'm going to show quickly about our container platform, what it is, what it does. Then I'm going to jump into the demo and I'm going to demonstrate how to set up basically with one single configuration file, with one single command, how you deploy highly available WordPress site backed by a Galera MariaDB cluster. The talk slot is quite short, so let's keep the questions kind of afterwards from the presentation, and then of course during the networking time you're free to grab my sleeve and ask anything, and I'll try to answer. Yeah, so basically, I mean, the world is going rapidly towards deploying everything in containers, and more specifically, people are mostly talking about Docker containers. So what they mean is it's kind of a virtualization model where you can actually deploy multiple different applications on top of the same container engine running in a host. So basically, you can easily package your different applications, whether they are WordPress or something else, and really easily deploy and run them on top of one container engine. So that's the short version of it. The longer version would take half a day or so. So let's keep it short at this point. Running containers is really easy. It's basically one single command to run MySQL instance. Right. It looks pretty simple. But in reality, it's usually something a bit different. So you really have to understand what you're doing with containers, and of course we promote our stuff, so you really have to have something on top of Docker that you use to orchestrate everything. Because doing things manually, well, it's a manual work and doesn't make sense. It's 2016 already. You shouldn't be doing any manual work anymore. We have computers to do that sort of things. So Kontena platform it's really an open source project or bunch of open source repos from GitHub point of view, and it's basically a container and microservice platform. And the number one goal for us is always maximize the developer happiness. Remove all the obstacles from developers that they don't have to really care about the underlying systems, underlying Docker, for example. They just can deploy their apps and be happy. They don't have to worry about anything. Works anywhere, any cloud provider, in your basement. We've heard people actually putting it on Raspberry Pis. I haven't seen it, but I've heard of it. So basically, our stack consists of a couple of things. The most important thing is a grid, which is basically a cluster of nodes running somewhere, maybe on Amazon, maybe on DigitalOcean in your basement. We don't really care. And those we combine as kind of one big Docker engine. On top of the grid, we automatically create an overlay network. So basically, whatever container, whatever service you run in the grid, it's always connected to this private overlay network, which actually is secure and can do also pretty weird setups using multi-hop routing. So you can have some of the nodes in Amazon, some of the nodes in DigitalOcean, some can be running on my Mac as virtual machines, and it just works. All the services, whether they are running on my Mac or in the Amazon nodes, they can just talk to each other as in local network. And everything's secure, encrypted traffic between the public hops or internet traffic. We do have an service discovery also built in. So basically, every service that you run gets a DNS name. Whether you scale it up, scale it down, the DNS is automatically updated, so you don't have to worry about okay, what IP does my container have today, and configure that to somewhere. So you can always refer to different services by internal DNS names. And DNS, well, covers like 98% of the service discovery use cases, at least to my experience. And if there's something more needed, there's always the etcd key value store available in the cluster, so that can be used for application specific needs if really needed. Of course, the kind of main functionality of the system is the orchestration. So whenever you specify that, okay, I want to run now my WordPress as an application, our orchestration layer takes care of that you have the necessary container instances running on some of the nodes. Or even in a specific node, if you're configured that, okay, this application has to be run on that node always. In case you have some, let's say, some dependency to some legacy Oracle database in the basement or something. And then, of course, from the user and from the developer point of view, the most important thing is the actual workload, the actual services, the applications, your stuff that's running on top of all these layers. On the node level, the only requirement that we have for the nodes is basically Docker engine. And that's it. If you can run Docker on the host, we can run Kontena platform on that. Because all our internal components are actually, well, Docker containers. And the only thing that has to be kind of installed, not in a like traditional RPM way, but kind of installed, deployed as container, is the agent on the node. And when the agent starts, it then has the capability to orchestrate everything else that the agent needs on the host. Of course, it needs some utilities and those sort of things that it needs. But the agent is smart enough to put everything else in place and configure properly. For example, the overlay network, the user doesn't have to do anything. And of course, it has to get some more privileges than a normal container, because it has to be able to actually control the underlying Docker engine. So you get this kind of a Inception. Everybody knows the Inception, the movie. I mean, how deep is the stack of dreams? I mean, you're running on a Docker, but actually instructing the Docker engine, and well, it's a mind bender at some days. The actual state or the desired state of services, it's kept on a component called master. So that has the kind of the brains of the system. It knows how to orchestrate the containers on the different nodes, and that's where all the state is. So the agents are basically, and the nodes are kind of stateless in a sense that they can come and go. As everybody who's used, for example, AWS knows that well, the instances just disappear some days. The underlying data store we used on the master is actually MongoDB. So it's pretty easy to make a highly available setup. Just set up a couple of nodes for MongoDB and make them as a replica set. And you can run multiple instances of the master, and that's basically it. The biggest setup for the master that I know is actually 4 nodes for the master and 3 node replica set for the MongoDB, and that can handle pretty well already. And of course, the master basically provides a REST API, and to control the master and to control the services, we provide a CLI tool. But if something else is needed, it's a REST API. It's not that difficult to consume by anything you need. Well, our motto is that all batteries included. So we do have a built-in registry for your custom images that you don't want to share in for example, in Docker Hub or any other public repo. We even have a built-in VPN access, so you can access the secure private overlay network if you need. For example, for database maintenance or something like that. We have built-in load balancing. It's based on HA proxy. So basically what we do on top of HA proxy, we make it fully automatically configurable. So whatever happens to your services, the HA proxy configuration is always up to date. So again, you don't have to configure anything. And well, HA proxy, it's a pretty solid technology. It's quite battle tested, for example, in GitHub, so it should be quite bulletproof. We collect all the stats and logs from the services that are running. We do have a user management and this sort of a role-based access control. So you can assign different roles to different people that, okay, this guy can do something and this guy can only view the state of things and those sort of things. Plus we have a secret management out of the box. So you can securely store your database password, for example. You don't have to have it in some Docker configuration file or anything as plain text in GitHub. We all know that we shouldn't be doing that. Plus then we have a bunch of other things, but those are the most important for us. So, I mean, it includes pretty much everything you actually need to run services or applications. Well, how does this fit to now the WordPress, the sort of main agenda for this meetup? I mean, the typical deployment architecture for WordPress, it's pretty simple. You have something for load balancing, then you have your WordPress servers, Apaches or Nginxes, how do you want to implement it. You have to have some replicated database. Of course, we don't want to lose data, or, well, at least usually we don't want to lose data. Plus then you have to have this something replicating the files on the file system level for the offloads and those sort of things. And when you, I mean, from the architecture point of view, it's pretty simple. But when you are actually implementing highly available load balancing, highly available WordPress, highly available replicated file systems, and highly available database, it's actually a pretty complex setup. Well, let's do it in containers. So what we can do is, in the example, I have 3 nodes. So we can run start the Galera cluster for the database. We can start it on each of the nodes. It's pretty simple, straightforward. Just basically saying Docker that okay, run the Galera, give it some cluster name and those sort of things. Yeah, well, doable? No. I mean, you shouldn't be doing manually anything anymore, as I said. So let's do it properly with containers. So what I'm actually now going to show is a deployment of highly available WordPress site. So what I'm going to do is for the internet traffic, I'm going to deploy the HA proxy, the load balancer, on 3 instances. The WordPress itself, it's going to be also 3 instances running. To sync up all the kind of assets, the file uploads or whatnot, we use BT sync. So that's basically BitTorrent protocol sync between the nodes. So whenever I upload something, it's all automatically replicated to all the other instances. Then I'm actually going to deploy another instance of the load balancer to balance the queries for the databases. Because Galera cluster is active. So I can actually put the queries to all different nodes. And then of course for the Galera cluster, I haven't ever really figured out why it's implemented that way, but you have to have this weird seed node. If you ask me, it's a bad design, but let's not go there. Seems pretty straightforward, right? So let's pray that we don't have any demo effects. So are you able to read the font? Okay, cool. So basically, if you ever played with Docker or Docker Compose, the service definitions in Kontena, it's pretty much one-to-one. So you define your service, give it some configuration, and tell that, okay, what Docker image to use. So that's for the seed. And here you can see in action the secret mechanism that we have. So I'm not actually exposing anything, any passwords or anything in plain text anywhere. So I have actually configured all the passwords already in the secure vault that we have, because it would just take too much time in the demo. For the gallery itself, so we just basically say that okay, this is the node or the cluster that we are going to create. This is the extra backup password that's needed for the sync, and then that it's linked to the internal load balancer that we put on top of the gallery cluster. And then there's some configuration for the load balancer itself. That's actually the definition for the load balancer itself. Couldn't be much simpler than that anymore. And then of course the main beef of the thing, the WordPress itself. So I'm using this, it's actually a pretty old version. What's the current one, 4.7 or something? I mean, it's a bit old, but it doesn't matter. We give it these load balancer configurations, and then a bunch of secrets for these nonces and whatnot. And then the BitTorrent syncing thing, basically the only beef is this one. That we mount the same data that's actually in the WordPress service. And then we say that, okay, sync up this folder. So whatever I upload to the media in WordPress, it gets automatically synced. And then the sort of internet-facing load balancer from where we actually expose the ports to the outside world. And really deploy the whole setup. It's one single command. Imagine you would actually have to set up all the two different levels of load balancers, different clusters of databases. It would take quite a while to configure everything properly. Now it takes maybe a couple of minutes to deploy the whole thing. So basically what the master is now doing, it's figuring out that, okay, the guy wants this service and this many instances. It takes a look on the grid that, okay, I have these hosts available, what's the best place to put them on? And voila, done. So what I can do now is, I can go to you get these usual setup things. How many hackers do we have in the? Yep. I can create a new page. Let's add some media. Insert. Go away. Publish. Now when I hit the Control refresh, you can see that the image is there, so it's already synced between all the nodes. Because in the WordPress load balancer configuration, we said that okay, we want round robin. So basically every request is going actually hitting different instances of the WordPress. Of course, I'm not a WordPress expert myself, so probably you know the WordPress setup pretty much, well, a lot better than I do. But of course, the same way as we used the BT sync to sync up the media things, you could of course set up to sync up themes and whatever you configure in WordPress. Or then lots of people seem, at least based on my Googling, they seem to use the Dockerized WordPress so that they actually build in all their custom themes into the Docker image already. So that seems pretty viable option also. And this stateful flag is actually pretty important. It basically means that whenever we redeploy the WordPress service, we actually ensure you that the data that is there, we keep it there. So we just switch the kind of container and make it point to the exact same data again. So it's stateful in a sense that you can actually store data. Containers are cool, right? Well, that's my demo presentation. Sorry, I do have slides still. Wrong slides. I have too many desktops running. So if you're interested in Kontena, there's a few different ways how to kind of follow what's happening in our world. Of course, the usual Twitter things. As I mentioned, everything is open source. Feel free to use, give feedback, make issues in GitHub even better if you make pull requests. We do have a Slack channel also for discussions, for this kind of a community support. We do have different meetup groups. For example, here in Helsinki, I think there's 100 at least in the group already. Then of course we do have website, there's documents and everything